Alright, this is 1310. This is more classifications of quadrilaterals on a coordinate plane. This is the third lesson dedicated to this topic. And they're saying after this one, what makes this one different? Well, let me see what they say about it. You can use a coordinate geometry to classify quadrilaterals based upon their mathematical coordinates and some equations. So it's no different. It's almost like they really want you to know how to do this. So you should probably know how to do this. Anyway, so this time is going to change it up a little bit. They're going to give you an image on a coordinate plane. You're going to have to pull the points off and then do the same math you've been doing, and then they're gonna again do the give you some points, and you're gonna have to do the same as math you've been doing. So it's just more practice, really. So let's get to it. All right, so here is some points. Let's zoom in so you can see it a little bit better. There's point P. First thing you do is you probably just want to go ahead and label the points. All right, this is obviously 0, 0, 5. That is that point. Okay, point T is -2, 4. That's point T. Okay, and then we have point R down here at -2, -3. And then we have point A at 0, -5. This gives you a good visual representation of how long these line segments are, and it'll help you actually figure out the length of these things. This, with the visual reference, it actually makes it a little easier. Okay, so let's get to it. Alright, so let's see. Let's figure out some stuff here. It's pretty obvious here that the slope of R and T, slope of R, T, and the slope of PA, and the slope of PA are both equal, and they're both undefined. Defined, undefined. Right, I'll just the symbol for undefined is a 0 with a both undefined. Right? Oops. Right, because my change in x is 0, and I can't define. And remember, my slope is my change in y divided by my change in x, and my change in x is 0, so I have an undefined slope. There is no slope. Okay, so these lines here are parallel. Okay, now these lines parallel? Well, I don't think so. Let's see what the slope of line TP is. Line TP slope is my change in TP slope. TP slope is my change in x. Slope of TP is my change in x. Oh, it's 1-to-1. Look at that, just 1-to-1. Its slope is 1, and it's up. So and my slope here is -1. So they are opposite slopes. So TP and RA. TP, slope of TP is the inverse and opposite of, well, let's write it like this. It's the inverse and opposite of RA. Therefore, they're perpendicular. Okay, well, that's interesting. That's interesting. Okay. All right, so what about the side lengths? What about the side lengths? What are the lengths of these sides? Well, I have this is, my change in x is 2. My change in y is 2. So 2 squared plus 2 squared is the square root. So this is the square root of 8. So my TP is 2 square root of 2. And then, oh, that's the diagonal. That's TP equals 2 square root of 2. Is it? Let's see. So that's 2. That's 2. 2 squared plus 2 squared equals, yeah, it's that's going to be 2 square root of 2. Okay? That's not the diagonal. The diagonals do this. What am I thinking? So these side lengths are 2 square root of 2. RA equals 2 this way, 2 that way, and 2 that way. Okay, so that's going to be 2 squared root of 2 as well, because it's 2 squared is 2 is 4, 2 squared is 4, or is 4, 4 plus 4 is 8 squared, which is 2 square root of 2. Okay, if you can't figure out why I got 8 squared, if I go square root of 8, right, so it's 2 squared plus 2 squared, right, that's what I got. 2 squared, both 2 squared plus 2 squared, that's the square root of 8, which is 2 times 4, pull out the perfect square root, so it's 2 square root of 2. That's where I got that from, in case you were trying to figure that out. Okay, so that's those lengths, right? So if I was trying to figure out this length, right, PA is just 10. It's no change in x because it's up and down, and it's 5 negative 5, and there's no change in x for TR, so it's just, it looks like it's 7, right? So those are my lengths, my side lengths there. How about my diagonals? Right? My diagonals, it's just going to be, well, I'm going to do this in orange. This one, diagonals from here to there, and from here to there. Those are the diagonals. Okay, so let's figure that one out. So here's a triangle for my diagonal. And my change in x for my diagonal is 2 squared. So this is RP. Change in x for my diagonal, RP, right? RP is my change in x is 2, right? Because it goes from 2 to negative 2. My change in y is, that's negative 3. And negative 3 to 5 is 8. Right, so plus 8 squared. Okay, so 2 squared plus 8 squared, 2 squared plus 8 squared equals, it's the square root of 68. So let's see, 68 divided by 2. 68 divided by 2 is 34. Divided by 2 is 17. So this is going to be 4 times 17. I can bring out the 4. That's the square root of 4 times 17. So I bring out the 4. You bring out the 4, make it 2 square root of 17. Alright, so that's going to be equal to 2 square root of 17. Alright, so that's that diagonal. This diagonal right here, TA equals the square root of, let's see, this is 1, 2, that leg is 2 squared, plus negative 3 to, oh wait, no, negative 4, or 4 to four to negative 5. Hold on a second. Let's see. This is, oh, I mislabeled that. That's 3. There we go. That's 3. 3 to negative 5. 3 to a negative, which is 8, plus 8 squared equals, the only reason I mislabeled that is because the math wasn't making sense. Oh, the only reason I've noticed I mislabeled that is because the math wasn't making sense. Equals 2 square root of 17. I wasn't expecting that to not be a nice isosceles triangle. All right, so the diagonals are equal, right? The diagonals are congruent, right? These lines are parallel. I have RT and PA are parallel because they have the same slope. So, and RA is congruent to RP or RT, or is that, no, PT, is that a P? Yeah, to PT, right? Those three things combined. So this is congruent to this. These are congruent, the diagonals, and this, and that's enough to say that's an isosceles trapezoid. No, this would be a CELES trapezoid. That's an isosceles trapezoid, right? So that is all the work for that one there. Okay, so I was able to deduce all that stuff because of that, right? Recognizing that here is one of the work for that diagonal, and then the other diagonal work is right here. Right here. You could have done this too down here. You could have done it like that if you wanted to, but that would have worked as well. That's the other diagonal. Right, so figuring out the diagonals that way. Okay, so hopefully, oh, let's do this one. Let's do the ones on the back. There's no picture, but there's points. Okay, so let's get to that one here. And we have these points of these four things. So let's figure out the slopes of all this stuff. Okay, so let's figure out S to C, S to K. All right, so let's figure out the slope of S to K. All right, so where am I going to put all this stuff? All right, I guess I have room up here to write. The M, I'll do the M's right here. That's my slopes. All right, so S to K, SK slope equals my change in X and my change, remember it's my change in Y divided by my change in X, right? and this is my final, right? If I'm gonna go like a line, AB, this is my final, and this is my initial, okay? So that's my stratagem. That's the way I go at it. All right, so K is my final, and S is my initial. So my Y value is 3 minus 3 negative, so my S is 6, right? And my Y is 1 minus 6, or my X value is 1 minus 6, so it's negative 5. Negative 5. Right, so this is a downsloping that can't be reduced, so I'm going to write it as negative 6/5 for SK. So SK equals negative 6/5. Okay, how about KW? KW, okay, all right, KW, so W is my X, or W is my final, and K is my initial. All right, so WY, my Y value W is negative 2, and minus 3, right, is negative 5. My X value is 5 negative minus 1 equals negative 6, right? So it's positive 5/6 equals 5/6, right? So KW equals 5/6, which is the opposite reciprocal. So these are parallel. Correction, these are perpendicular. Those are perpendicular because it's the opposite reciprocal. Okay. So that's something. All right. So then we're gonna do the same thing here. Let's do a this ends up being a square, I bet. I don't want to do another square with you guys. Yeah, that ends up being a square. I don't want to do another square. All right, let's do this one instead. All right, so let's do, all right, so what's the slope of this? All right, so we got 5 again. We have your A, B, final, initial, and your delta is your final minus your initial. Okay, so what is GN? So GN slope is your slopes. N is 1 minus G is 8. 1 minus 8 is, so your 8 is negative 7. Negative 7. Okay? And then your X is going to be N 1 minus 5, which is negative 4, which, so that ends up being, GN ends up being 7/4. So negative divided by a negative is a positive. All right, so that's an upslope. Okay, now let's look at your, looks at NT. Let's look at NT next. All right, N start at T is my ending point, so it's going to be negative 7. Negative 7 minus 1, so it's going to be negative 8. Negative 8 divided by my changes in y minus 1 nt minus 1. Right, so it's going to be it's going to be negative 8 over negative 1, so nt equals 8. Specifically 8 over 1, but I'm just going to say that it's 8. All right, so then we have, next is th. Next is th. I'll put it over here. th, starting with h, we have 0. My h, and then my t value is minus negative 7, so that's 7. So minus a negative 7 is plus 7. My h value is 4 minus, I'm sorry, th. No, that's right. 4 minus 0 is 4. So that's going to be 7/4. So th is 7/4. Hey, th is parallel. Th is 7/4. And those are parallel. GN and TH are parallel, right? Because they're both 7/4. And I bet NT is parallel to GH. So GH, okay, so this should be HG. I'm going to keep up with the labeling. HG equals, alright, so G is 8 minus 8 minus 0 is 8. Wait a second. Oh no, it's HG. It should be HG. Okay, so G is 8 minus 8 is 8 over, change some y's, over my 0 point, which is h, which is 5 minus 1, which is 1. Right, so that's going to be, either way, even if I put it as hg, it would have been negative 8 over negative 1, which would have been, 8. So, which is still perpendicular to nt. hg equals 8. Alright, so I have two parallel lines, right? But these lines aren't perpendicular to each other. Right? They're just two sets of parallel lines, so I at least have a parallelogram. At least it's a parallelogram. At least. Now I wonder if these line lengths are the same size. Alright, so let's, what is GN lengths? What's GN's length? It's going to be the square root of, alright, so GN, that is, let's see, the length of that is 4. My x's length of that is 7, which equals 4 squared plus 7 squared equals 65. That's the square root of 65. Square root of 65. How about NT? Oh no, let's see if the THs are congruent. Let's see what the hell it's like with TH. How about TH? TH is 7. So 7 squared. And then 4. Yeah, that's the same. Okay. And then how about NT equals square root? NT is, let's see, NT, looks like we have 7, negative 7. That's going to be 8 squared 8 squared plus NT1 plus 1 squared equals 60 squared root of 65. Oh wow, okay, 65, and then we got HG. I bet it's the square root of 65 equals 8 HG 8 squared, and then yep, plus 1 squared equals the square root of 65. So all these lengths are the same. So it looks like we have nothing, no 90-degree angles, right? No parallel lines, no perpendicular sides. I bet let's see what the diagonals say. Let me zoom in a little. All right, so no perpendicular sides. What about the diagonals? So the diagonals would be like GT, right? Because it's jumping from this one to this one. That's a diagonal. And then NH. That's the diagonal. So square root of the changes in x's. GT would be like 4 squared plus 7 squared. No, wait a minute. Hold on. I'm not sure if that's right. It's GT, oh yeah, 5 squared. Reading the wrong one. Plus 8, that's 15 squared. Okay, which equals 5 squared plus 15 squared equals square root, which is this is the square root. That's the square root of 250. Square root of 250. I can divide that by 10 and 20. 10 times 25. So that's 5 times the square root of 10. Yeah, which equals 5 times the square root of 10. And then NH equals, NH is 3 squared. 3 squared plus 1 squared plus 1 squared, which is 9 squared, which is the square root of 10. Yeah, that's the square root of 10, which is the square root of 10. Square root of 10. So they're not the same. Yep. So they're not the same. So I think we have, so let's kind of sketch what we got. All right, so we have things that aren't the same. We have 2 lines that are parallel, right? 2 other lines that are the same length. And it looks like we kind of have like a rhombus going on. The diagonals are the same length. It's like, yeah, that's a rhombus. It's a rhombus because all 4 sides are congruent. Yeah, so all the 4 sides are congruent. They're all the square root of 65. That's square root of 65. That's the square root of 65. Let's see, and like this is the square root. This is the square root of 65. And like this is the square root of 65. Right? But this length is like 3 times the length of this length. So this should be like squished a little bit. This should be like squished a little bit. But anyway, so yeah, that's how you figure out this whole thing. All 4 sides these are all congruent, right? There's 2 parallel sides, right? These sides are these sides and these sides are parallel, right? And there are no there are no perpendicular sides. All right, so because of that, it's a rhombus. Okay, that was longer than I thought it would go, but hopefully that helps you out, and that's kind of how you solve these things. Hope that makes sense. I have a hard time drawing rhombi, but anyway, you have a great day.